So what is process state? So the current activity of the process, it is recorded by an operating system, and that current activity of the process is called as process states. So there are different states of the process. So the first state of the process is called as new state. Now, what is the meaning of new state? So again, let us consider the C program. So you have written a C program. So program, it is nothing but a set of instruction. After that, you have saved that program onto the secondary memory. So when you are saving the different programs onto the secondary memory, then we can say that your process, it enters or it goes into the new state. That is, your program is ready. Your program is ready and it is saved onto the secondary disk. Then your process, it enters into the new state. Okay. After that, your program is already ready and it is saved onto the hard disk. But now when you want to execute that program, when you will compile it, and after that when you will run it, so that time your program, it is converted into the process, because program under execution, it is called as process, and the program, it is executed into the primary memory. So when the process or program, it resides into the secondary memory, then it goes into the new state or it represents the new state. And when you run that program, that time it required the primary memory. So your process, it is shifted from secondary memory into the primary memory. Then we can say that process, it goes or it is shifted from new state into the ready state. When the process is created and it is saved onto the secondary disk, then it enters into the new state. And when we run that, then the process from the new state, it goes into the ready state. Now now the third state is there. That is suspend state or ready state. So initially the process is created, so that resides into the secondary memory. After that, when you run that process, then that process, it goes from new state into the ready state. That is, that process, it goes from secondary memory onto the primary memory. So it enters into the ready state. So now in the multi-programming environment, number of processes are there which are running by your CPU. So if multiple processes are there, so at a time your CPU, it can execute only one process. Okay. So in the multi-programming environment, suppose number of processes are saved onto the hard disk, and now you want to run that. So when you will run that, that process, it will be shifted from the new state into the ready state. But here assume that because of the multi-programming environment, your ready queue. So queue is maintained by the operating system in the multi-programming environment for keeping all the processes in a queue. So let us consider that queue, it is already full. So if queue is all this ready queue, if it is already full, so your process is already created, then it already shifted into the ready queue. But now ready queue is full, then that process, it will get suspended and it enters into the suspend ready queue. Means process is ready. What is the meaning of suspend ready? Process is ready to execute, but as the ready queue is full, it is shifted into the suspend ready queue. Now see, now let us consider that in the ready queue, 100 processes are there. Okay. And now these processes are ready to execute. And if your CPU is free, then your operating system, it will collect one of the process from the ready queue, and then that process, it will get dispatched, or your operating system, it will dispatch or schedule that process. Means that process, it will get shifted from ready queue into the run state. Run state means currently your processor is executing that process. Okay. So if one of the process, it is held by the CPU, its meaning is that your processor is running or executing that process, then that process, it enters into the run state. Okay. So if in the ready queue, 100 processes are there, and now one of the process from the ready queue, it is shifted into the run state, then that time, suppose at a time only 100 processes that can be there into the ready queue. So if one process is shifted from ready queue to the run state, that time the process which is already shifted into the suspend ready state, now that will get moved back to the ready state. Okay, because now one of the process is moved from ready to run. Because of that, the process which is residing in the suspend ready state, that will get shifted into the ready queue. So this is called as resume. That is when the process is ready to execute. Because ready queue is full, because of that it is placed into the suspend ready state. Now the ready queue, one of the process is shifted into the run state. So because of that, again the process which is residing into the suspend ready state, that is resumed, or that will get shifted into the ready state. Now let us consider that if you are using the time sharing environment. So in the sharing environment, limited time is allocated to each process to use the CPU. Suppose 5 seconds or 10 seconds are allocated to each process, and only for 5 seconds that process can use that CPU. So one of the process is shifted from ready queue into the run queue. Now run into the run state, and now currently your CPU is executing that process, but only 5 seconds are allocated by an operating system to that process. So once the time slot which is allocated to that process, it will get over. Means here process it is not executed completely, but time slot allocated by the operating system is over. Then that time process is yet to complete. That time your process it will get shifted from run state into the ready state again. Means process is ready, but it is not completed. Its execution is not completed by an operating system. So that time your process it will get shifted from run queue into the ready queue because of the time quantum which is assigned to that process. This is the one of the reason that why the process it is shifted from run queue into the ready state. Now, from run state into the ready queue. Another reason is priority. So in the operating system, different priorities are assigned to the process. That is highest priority and lowest priority. So in the Unix or Linux system, these priorities are given as 1, 2, 3, 4, 5, 50. So for example, if lowest number 1, if it is representing the highest priority, and the highest number if it is representing the lowest priority, then in the Unix system, whenever the processes that are entered into the ready queue, that time your Unix system it will compare the priorities of the process. Suppose currently the process which is executing into the which is executed by the CPU which is in the run state, if priority of that process if it is equal to 100, and priority of the process which enters into the ready queue if it is equal to 1, lowest number if it is representing the highest priority, when the highest priority enters into the ready queue, that time what will happen, then your CPU it will give that CPU time to the process which is having higher priority. So the lowest priority process that will get shifted from run state into the ready state, and that CPU it is assigned to the highest priority process. So if the processes are executing by the CPU or by the processor, then that are shifted into the ready queue because of the time quantum. That is, if the time which is assigned to them, if it is finished, then it will get shifted into the ready queue. Or if some higher priority process it will come into the ready queue, then also the lowest priority process it will get shifted from run state into the ready queue. So these are the two reasons why the processes are shifted into the ready queue. After that, next, now let us consider that currently you are running the C program, and that time you have written a statement that enter the value of A and B. So if you have written that statement, then your program it will display a message on the computer screen that enter the value of A and B. So in that case, your process, it will require the input output resource. That is, it will require the keyboard, because through the keyboard user will enter the number. So in that case, your process, it requires the input resource. So that time your CPU, it remains idle. So in the multi-programming environment, whenever your process is requesting for the input resource, that time your process, it will get shifted from run state into the wait or block state, because now your process is blocked, or it is waiting for the input which is entered by the user. So when the user will enter the input, then only your process it can continue its next job. So whenever it will request for the input, or whenever it will request for the output, suppose you are taking the printout, then that time you will request for the printer. Then your process it will get shifted from run state into the wait or block state. Okay. So this is the nothing. This wait and block, it is representing the process which is requesting for the input output resources. Okay. So now your processor is empty now. So if one of the processes is requesting for the input resource, that time your operating system, it will pick up the another process which is present in the ready queue, and that will get shifted into the run state. So this is called as multi-programming environment. But now let us consider that if you are requesting for the input from the user, and if user has entered value of that two variables, means here input job is completed because you have taken value from the user. So now here operating system, it will shift the process from wait or block state into the ready state again, because here you have received the input from the user, so it will not directly shift that process from wait or block state to the run state. Instead of that, it will shift that process from block state into the ready state, and again that process, it will wait for its turn, and when it will get its turn, then it will get shifted from ready queue to the run queue. It is, we are not directly shifting, operating system is not directly shifting the process from wait queue into the run queue. Okay, so after that, next, now see here, you can see that sustained waits, this is the wait and block state in which the process is waiting for the input output resource. But now let us consider that if in the wait and block queue, suppose this is the queue, this is representing the queue, and in this queue, it can hold only 100 processes, and suppose now currently the 101 process is running in the CPU, and now that process, it requires the keyboard, that is, now this process, it is requesting the user that enter the number, that is, it require the keyboard. But now if this process is representing the higher priority process, that is, if the priority of this process, it is higher than the process which is present in the wait and block state, then in that case, what will happen, the process which is waiting for the input output resource, that will get shifted from wait block state into the suspend wait state, and the process which is currently using the CPU and which is requesting for the input resource and which is having higher priority, that will get placed into the wait and block state, and this process, it will get shifted into the suspend wait state. Okay, and now once the input output job of this higher priority process is completed, then again it is placed into the ready queue, and now this queue is free, so the process which is present into the suspend wait state, that is resumed, and that will get placed into the wait block state. Okay, and now let us consider that the input output is let us consider that here one of the process is present in the wait block queue, and now it is waiting, ready queue is already full, ready queue full है, यहाँ पे एक process है, उसका input operation complete हो गया, means user has entered the value, its input operation is full, but it is not shifted to the ready queue because ready queue is full. So in that case, that process, it will get shifted into the suspend wait state. So suspend wait state means that process is there whose input operation is completed, but it is waiting for the CPU. So in that case, input operation is completed, then that process, it will get shifted into the suspend ready state. Means input output operation is completed, that process is ready to execute, so that will get shifted from suspend wait into the suspend ready state, and when the ready queue is free, again that process, it will get shifted from ready state to the ready queue. Okay, suspend ready state to the ready queue, and when the process, it will get completed, and if it is longer require the CPU, then that process, it will get shifted from run state into the termination state. So this is the process state transition diagram.